Live. Okay, good. Okay, so it's March. Yay, 3-1. If it would only act like March, that'd be great, huh? Okay, so today our objective really is we're going to look at all of the aspects of polynomial graphs. Okay? So, polynomials are unique graphs because they roll. Does that make sense? We've kind of seen that, right? And the more terms you have and the bigger the degree you have, the more it will roll, okay? So what we want to do is talk about local maximums, local minimums, and inflection points, okay? So the local max is, in a sense, the top of a hill. Does that make sense? Local max is like the top of a hill. And the reason we call it a local max is because if you take a look at the darn thing, at some point it's going to take off to infinity, right? Does that make sense? So then you can say, well, where's the max? The max is at infinity, but it has this bump, would be a local max. Got the I mean, that seems obvious, right? Same thing with a local min. Local min would be the bottom of the hill. In calculus, you guys are going to do a lot of this, but you're not going to use your calculator. You're going to use calculus to get, okay? And again, same thing on a local minimum. You have to call it a local minimum because, you know, some graphs go forever down, and the minimum would be at negative infinity, right? So that's what you call a local minimum. Now, the inflection point is where it changes. So it's going to, an inflection point is where your graph will change from concave up or down to concave down or up. And I'm going to give you just a really easy little picture on the side so you can see what an inflection point is, okay? I don't know, if you guys listen to the news, every now and then they talk about an inflection point in business. And then at your age, you like have no clue what they're talking about. But if you know some things about math, okay, a great example of an inflection point would be like this, okay? You got a business, okay? We got a business and we're doing great, okay? Then all of a sudden, we decide we want to open a new store. Okay, think about income in my business. So we're doing great, but then all of a sudden things start to slow down, right, in our business. And so we think, oh gosh, you know, if we open up another store, then we can make some more money. So once you open up that new store, you're going to go and start spending some money. Does that make sense? So your income goes down. Think about it as a business model, right? And then all of a sudden, at some point in time, you know, you lose money because you're paying the bank, you're paying people to build that store, and then all of a sudden, you're still losing money, but then your new store starts to take off again, right? Your inflection point's right about there. That would be your inflection point. So in business, they talk about an inflection point because it's the time either it starts to turn back into a good thing, because all of a sudden you're not losing as much income. It's slowing down. The rate at which you're losing income is slowing down. Does that make sense? Think about this as in terms of slope. All of a sudden you're going, oh crap, we're in trouble. Right? And then we're going, oh, I think we're going to get out of the woods. We're still losing money. But a lot of businesses will go a couple of years losing money, knowing full well that it will turn around. Does that make, you guys have you seen examples of that? Your big businesses might lose money for a couple of years, knowing full well that at some point in time it's going to turn around and start gaining good money, okay? So that's where an inflection point is. Easiest way for us to find the inflection point is really in between your max and your min, isn't it? Right? It's in between your max and your min. Here's my inflection point. Now when I say concave up and concave down, do you see where it's concave down? This is my concave down part. And then here's where it all of a sudden becomes concave up. And it has to do with slope more than anything. You see your slope at this point, technically your slope is 0 here. Does that make sense? Your slope would be 0 here. And then your slope becomes negative. It's becoming more and more negative. And then it hits the inflection point. The slope is still negative, but it's less negative. You get to 0 here for slope, and then all of a sudden your slope becomes positive. You're making money, okay? Anyway, let's take a look at example 1. So the first thing I'm going to do in example 1 is I know for sure I'm going to have zeros at -3, right? And I'm going to have a 0 at x equals negative 2 twice. Okay? Oh, positive 2, my bad. Okay? So I know the graph is going to look something, and I'll use my pencil because I'm going to erase it. I know my graph is going to look something like this. And I'm going to use my pencil because I'd like to get a little bit more accurate, okay? Does that make sense? Okay? I know that because it's a positive term here, it has to finish toward infinity. If this were a negative term here, it'd finish down towards negative infinity. I also know this is a double root, so it's a touch and go here, and here it is at a 0 of negative 3. Okay, now exactly what it is, I don't know. I'm going to erase what I have. I know it's going to look like that. Let's get some better values, okay? So one thing I can do real quick is I can get my y-intercept. So I've got my x-intercepts. Here's my x-intercepts. There's my x-intercepts. Now my y-intercept is when I let x equal 0, right? So y-intercept, let x equal 0, okay? So if I plug in 0, I'll go y equals 1/6 times 0 plus 3 times a 0 minus 2 squared. And that's going to give me my y-intercept, okay? 1/6 times 3 times 4, right? You guys okay with the 4, negative 2 squared, right? Or 1/6 of 12, which is 2. Okay, so I'm going to have, I was pretty close. Wow, okay. Now, local min, local max, and the inflection point. Let's use our calculator to get that. We aren't in calculus yet. Someday we'll be in calculus and we'll be able to find out these using calculus. But let's go ahead and just graph, okay? So I'm going to go ahead and take my calculus, go y equals, clear that, and let's type in my 1/6. So I can go 1 divided by 6, parentheses, my 1/6, x plus 3 parentheses, x minus subtract 2 parentheses squared, right? And I'm going to put it, I'm going to graph it now. Alright, now one of the things I like is I've got my min right at the back. I don't need to do a trace button on my min at all, okay? So I know my minimum is at, my local min is at the point 2, 0. You guys okay with that? It's right there. I saw that from my calculator. There's my minimum at 2, 0, okay? Okay, now, my max, we can get my max by just using second, calculate. Let's get my maximum, right? So I'm going to go to my left bound. Remember how we did this? Am I going too fast? It was right there, which is at 2, 0. Okay, yeah, and stop me if I get going too fast, Gavin. Please just say, Mr. Davies, you're going too fast. Slow down. Okay, won't bother me. Okay. All right. Guess. Right. So there it is, and it's about a negative 1.333, which is about a negative 1/3, and about a 3 point. We'll round it to 3.1. Okay. So my local max is at about a negative 1/3, comma, about 3.1. Okay. Yeah. Thank you. 1/3. Thank you. Now, that's pretty easy, right? Now, what about this darn inflection point? I mean, we could kind of guess where it's at. I mean, I'm thinking it's right around here somewhere. Probably awfully close to 2, right? But how could we get it? Well, it's got to be, the inflection point's got to be halfway between, let me go ahead and highlight the 2 points, put it in here, negative 1 1/3, 3.1. My inflection point is halfway between these 2 points, right? So let's figure out what is between, so what is that distance between, I've got a 2, right? And I've got a minus 1 1/3. See, I'm trying to find the distance between them. Does that make sense? Find the length between them. So what's the length between 2 and a minus 1/3, which is going to be a 3 1/3, right? Okay, so the distance between these two from here to here is 3 1/3. Okay, let's get a visual, okay? So the inflection point lies in the middle of this distance. Okay, so all I did is I took negative 1 1/3 and 2 and I found the distance. You with me? Okay, now it's got to be in the middle of this, correct? So if I take half of this distance, think about it, if I take half this distance, then I can move it over half that distance and I'll get the inflection point exactly. Do you want me to say it again? Okay. The inflection point lies right smack dab in the middle of this, right? So the width of this is 3 1/3, okay? So if I take half of 3 1/3, have I lost you? Okay, if I take half of this length, this distance, then I'll take that length, that distance, and I'll go over that half amount. And I'll be right at the inflection point. Thumbs up? Does that make sense? Okay. So now we got to do a little fraction work. I can handle that. So that's the same thing as a 10/3. You okay with 10/3? 3 times 3 plus 1. And if I take half of that, that'd be 10/6. If I take half of that, okay, which is what? 5/3. If I reduce that, I know fractions are always tough. So if I go to this point, which is at negative 1 1/3, and I add 5/3, or if I'm going to add a 1 2/3, it'd be right about here at 1/3. Okay? So this x value of the inflection point will be at 1/3 something. Well, how do I get its corresponding y value? Let's just plug it in, right? Let's just plug it in. So I'm going to plug it into my original. So, okay, I'm going to go negative 1, 6 parentheses. I'm going to go a 1/3 plus 3 times a 1/3 minus subtract 2 squared. And I get about a 3.08. We'll round it about 3.1, okay? Oh, that can't be right. Let's try that differently. Oh, I didn't do a 1/6. My bad, let's do it again. You guys gotta catch me when I make my dumb mistakes. How about 1/6? That's what I didn't do. And I'm gonna do my 1/3 plus 3 times my 1/3 minus 2 squared. There we go, about 1.54. Okay, so my inflection point's about 1/3 and about a 1.54, 1.5. Okay, so a lot of fractions, but let's go back to the easy part. The easy part, so we don't get ugly numbers, but your inflection point is going to be in between your max and your min. Does that make sense? So the way I got that is I figured out what was the distance between them. What was the distance between them, the width. I took half of that, right? And I found my inflection point right smack dab in the middle. That makes sense. We can get away from messy fractions. That's basically it, okay? So you guys want to turn the page? Let's do it again. Okay, let's do it for a second time, okay? So here it is. 6x cubed minus 5x squared minus 17 minus 6. And I think this might have been the exact same problem we did in our warm-up, isn't it, for zeros? Okay, so we'll do it again. So real quickly, I think this is exactly it, wasn't it? Yeah, so we know the zeros already. You guys agree? This should say graph. I can't spell. So the zeros, and we got the zeros in our warm-up today. And what were they again?
-2, 1.5,
And
and 1/3.
negative 1/3. So it's negative 2, 0, 1.50, and negative 1/3, 0. Okay, everybody agree with that? So at least that saves us some time. I did that on purpose. Do you think maybe? Did that on purpose, save us ourselves a little bit of time? Let me make this a little bit darker, okay? 5, 0. Okay, we got that from the calculator. So now, how about max and min? So let's graph it and see what it looks like. Okay, clear that one out, and I'm going to go as 6x to the third plus 5x
squared, subtract 17x, subtract 6. Graph, and I think I might have to change my window a little bit. Yeah, I got to change my window. So what I'm going to do is two things. I'm going to make it a little bit taller, and I'm going to squeeze it in, okay? Watch how I do this. So I'm going to probably go on my window, probably -5 to 5, right? And I'm probably going to go a little bit taller, maybe -15 to 15. I might get a better picture. Oh yeah, it's a much better picture. You guys agree? Much nicer picture, okay? So let's find our max. Okay, so calculate. Let's go for our maximum. Enter. Okay. Enter. Enter. Guess. So about a -1.3. So my max is about a -1.3 comma about 11.4. Okay, let's go after our min. Okay, so second, calculate. Let's go to our minimum. Am I doing okay, you guys? I'm not going too fast? Okay, let me know. I can go too fast. You've seen it. Enter. Enter. Guess. Okay. And about a, so our minimum, our local minimum is about a 0.7 comma -13.4. Okay, so let's graph that. I might need to go by 2's on my y scales, right? So I'll probably go 2, 4, 6, 8, 10, 12. There's 12. There's 14. I'll go by 1's on my x scale. -2, -4, -6, -8, -10, -12. Okay, so 0's at -2, 0. All right. Let's see if I can get a different color. Okay. I want to use a different color. -2, 0 is there. 1.50 is there. 1/3 is about there. -1.3 and 11, possibly right about there. 0.7 and -13 is about there. Okay, so graph it in. Okay, now y-intercept, that's pretty easy. What's the y-intercept? What's the y-intercept? You guys agree with -6? I mean that, right? -6. If I plug in 0 for x's, probably don't need to do that. You guys agree? Y-intercept is -6. Thumbs up on that one, right? So y-intercept is going to be at 0, -6. Okay, now what about that darn inflection point? That's the hard one, right? Inflection point. Okay, if I take a look at my spread, so my spread is from -1.3 to 0.7, from my max to my min. I don't care about the y values yet, right? I just want to know this. From here to here, my inflection point is somewhere in the middle, correct? So where is it? Well, it's got to be in the middle between these two. So let's add these two. Okay, well, I'm not going to add the negative, but you're with me? That distance is going to be really, oh, we're going to get nice numbers, aren't we? So we get 2. So the spread is 2, right? Between here to here. You guys with me? The spread is 2. These are nice numbers for a change, huh? Half of that is distance of 1. So my inflection point is 1 unit over or 1 unit back, right? 1 unit either back or 1 unit forward. So let's just go 1 unit forward. So I went from my inflection point's got to be right smack dab in the middle. So I'm going to add 1. So I'll be at a -0.3, right? If I add 1 to that, something. How are we going to get to something? Plug it in, right? So let's plug it in. So my inflection point, I just took my -1.3 and I added 1, which gave me my -0.3 something. Okay, let's plug it in. I'm going to go 6 times my -0.3 to the 3rd power. plus 5 times negative 0.3 to the second power minus 17 times negative 0.3 minus 6, and I get an answer about negative 0.612 over negative 0.6, okay? How's that? Okay, now you may not thank me now because it seems kind of hard, doesn't it? But holy smokes, when you get to calculus, seriously, when you guys get